We use the chemical reaction 2 times DeH4 plus 6 ACO plus 2 H2 produce De2AC6 plus 6 H2O to create the compound De2AC6. We also know that the heat of reaction, or delta H, equals negative 12.2 kilojoules per mole. What we are looking for is the heat of formation of the new compound. We will use Hess law to determine the change in enthalpy of De2AC6. Hess law states that regardless of the multiple stages or steps of a reaction, the total enthalpy change for the reaction is the sum of all changes, where final delta HF minus initial delta HF equals delta H. The standard enthalpy of formation, or standard heat of formation of a compound, is a change of enthalpy during the formation of 1 mole of the compound from its constituent elements, with all substances in their standard states at 1 atmosphere. It is a constant number for each compound, so for solving this problem, the equation should be the final heat of formation, delta HF De2AC6 plus 6 times delta HF H2O minus the initial heat of formation, 2 times delta HF DeH4 plus 6 times delta HF ACO plus 2 times the delta HF H2, and it equals the heat of reaction, which is negative 12.2 kilojoules per mole. We have already been given the heat of formation for all the compounds in the reaction except for De2AC6. The heat of formation for ACO is negative 179.5 kilojoules per mole. The delta HF for DeH4 is negative 1098.1 kilojoules per mole, and the delta HF for H2O is negative 241.8 kilojoules per mole, and the heat of formation for H2 is 0. So we just need to plug in the numbers into the equation. So delta HF De2AC6 plus 6 times negative 241.8 minus 2 times negative 1098.1 plus 6 times negative 179.5 plus 0, and it equals negative 12.2 kilojoules. Through solving for the equation, we got that delta HF De2AC6 equals negative 1834.0 kilojoules per mole.